Hi and welcome back to the lab. And today here on the bench we have Yaesu FT-991A. And the radio came in because there is no output power on VHF and UHF. So let's see what we can do. Okay, and here is our 991A on or in the test setup, however you like. And well, you can see that the RF power is set to 25 watt and the radio is set to FM. However, when we now go and press PTT, we see it is going into transmit, but let's see, I mean, it is receiving, as you can hear. And let me go over to our tester. Okay, so let's transmit. Remember, we are on 25 watt. Let's see what we get. And yeah, not only a watt, so that is true. Let me go for full power. So that is 50 watt. Radio set to 50 watt now. Let me see. Yeah, 1.2 watt. So you see the frequency is right, so that is not the problem, but now it is dropping. Okay. Okay, so let me go to 70 centimeter just to check what we can see there. So it is set to 20 watt output power. Let me see what we got. 432, so that is right. And 1.3 watt. So we have here the same problem. We do not get full output power. I mean, I can also increase up to 50 watt. What does it mean? 2.7 dropping. Okay, so definitely we have here a problem. And I mean, as always, let's crack open and see what we can do. A first look here at the PA units, we have to say. We do not see any obvious. So here on the right hand side we have the VHF UHF PA, and we have here the HF PA, whereby you know, the driver here, so that is as well for our HF PA. So we have here a triplexer which is selecting the input signal, which comes here over this wire, and then it gets selected for VHF, UHF and HF. So here we have the connection cable over to our AF stage. So as I said, first look is nothing obvious. Well, to make sure that there was nothing really changed in the menus, I mean especially the service menus, we go for a full reset in order to be sure that we really have a hardware problem here. To perform a full reset, that is quite easy. So the only thing you have to do, press and hold fast and lock both together, press them both in, and then while they are in, start the radio, and we should have now a full reset. You see, everything is as it normally comes from a factory, so that is obviously fine. Okay, but even after full reset, we have the same situation, so we do not really get out power. So set to 50 watt as we can see. So that is now factory setting, but again we only get 1.1 watt maximum out of the radio. So for sure here we must have a kind of hardware problem. Alright, so the first what we can do is, of course, testing if our supply voltage gets here to our board, to our amplifier board. So let me check. Yes, voltage is there. What I'm interested in is if we also have our bias voltage present. Let me check. First of all, we have here nothing. Let's try to transmit, and yes, 2.4 volt. So that is also present, no problem whatsoever. Okay, and because I saw something suspicious here on the board when I was checking for the bias, let us look a little bit more here in depth with our microscope in order to see if there is something wrong. Okay, so here is a bias circuit, and oh, hello. Okay, so not sure if you can see it, but we definitely have here burnt resistors as far as I can see it. Look here. So that is very obvious that something happened here. So we should have here 47 ohm resistors, so that is the bias supply. So you can see, so that is a test point where I was testing the bias voltage, which was present 2.5 something volt, and now it has to go over the 47 ohm resistors and needs to supply the gate of our MOSFET power amplifier here. And you see both sides, because the power amplifier is a double package, right? So we have both sides which are obviously burnt. And well, when we test the value, so hang on a second. Okay, so let us test. I mean, of course you cannot read the meter right now, but let me say what I have. So 47 ohm should it be, and this one is 400 ohm. Okay, and what is this here? Oh, this is still 47 ohm, so this one is fine, even that we definitely have burning marks. And then let me go to the other side. Let's test this guy here. Okay, 1.8 kilo ohm instead of 47 ohm. And this guy here, what do we have here? Okay, so that only has changed a little bit. It is 51 ohm instead of 47. Alright, but anyway, here is something wrong, and that means we need to take the board off, because I believe that our power amplifier burned out. So that is what it looks like. Yeah, and once again, board view. Here's our little pot for adjusting the bias, and here is the first resistor string, and here is the second, right? Okay, and that you get a better understanding what we are talking about. So here, that is our power amplifier, right? And yeah, let's zoom in a little bit more, that you see what I'm talking about. First of all, it is a double pack, so you can see that. And now our gate, you find here our 4747, and then there is another one. So there is a 10 ohm, which must be on the other side. We have to check how that is, and you see it goes to the gate. And the second one is here. Here we have 47, 44, 47, 10, and then the gate connection, and both goes down here. Here is our pot where we tested the bias, and that is going, as you can see here, over the both 47 ohm resistor. Then there is a 10 ohm and to the gate. So that is how it works, and we see that this both and of course this both resistors as well are burnt, and so we need to take our board out of the chassis. And as we can see now, it takes a little work to do. So we have to unsolder here the connectors on our antenna connector, and some other connections, and as well a bunch of screws. So let me take it off and then we look underneath. Okay, so here's our PA board, and here's our power amplifier. It's a double pack MOSFET PA type. So we found here on this side that we have 4 burnt 47 ohm resistors, and here on the other side I said that there is additionally to what we have seen, we have here 10 ohm resistors. So here are 4 10 ohm resistors in parallel, but I cannot see that they burnt as well. So it is obviously only where do we have them? This both guys and this both guys, which are burnt. So what can we see at our power amplifier? So nothing really obvious. So because we have seen burnt resistors on the input side, so that means on the gate side, it is clear that we would check both inputs. So this is the first gate, or one of the both gates, and this is the second one. And of course we have here ground, if you like, and it is important to understand if both sides are still fine, and therefore what we really can check is that we both gates check against ground to see if the behavior on both gates are the same. If not, then that is definitely an indication that we have a problem with it. Okay, so my meter is in resistor test mode, and when we go here to the first one, which shows 2.1 kilo ohm, okay, not really telling a lot. And here we have, let's say, oh look, 47 ohm. So that means both gates are different to ground, which is definitely not really good. So what we can do as well, we go to diode mode and we do exactly the same test. So we test here the first one, let's say, and there we have now a voltage drop of 2.1 volt, which could be fine, because remember our bias is approximately around that voltage, so maybe that is not too bad. On the other side, what do we have here? And you see our voltage drop is only 40 millivolt, right? So that is definitely too low. Something must be wrong, I believe. And therefore, what we really need to do, we have to take our power amplifier out. We do not really know yet why it failed. So very often we have the situation that the adjusted bias is not really done good, so that the bias is too high, so that we have a too high drain current. So that is what often happens, or that somebody tried to adjust it for I don't know what reason. Well, then additional to that, we found in the past very often that there is not enough grease underneath, heat grease. In this case it is a little bit. For me it is a little bit too less. I mean, it is not good to put too much, but here, well, yes, there is something, but well, maybe that could be a potential reason as well. But okay, first of all, now we need to take it out, and as you can see how it is here soldered to the board, it is not an easy task, believe me. Okay, so as you can see, we have taken out here our power amplifier chip. So yeah, you really need to put a lot of heat into it to get it off, so that is definitely no easy task. On the other hand, we have down here our component, as you can see, and when we test it, you see it is recognizing by color LED 2 lead, and that's it on one side. And if we go over to the second chip here in the package, if we go over to that and we do exactly the same, and there no component detected. So what we can say, it is toasted for sure. We do not exactly know why, but when we put in a new chip, we definitely have to check if the bias current is adjusted in the right way. I mean, anyway, we need to readjust it, but maybe that was a reason for us here. Very important, we did not lost here a pet, so that is very, very good. So of course now we have to clean everything, and then I have already a new one here, so that needs to go in, and then hopefully when we have of course changed the damaged resistors as well, and then we can hope that everything is back fine. Okay, so everything is cleaned, and next step is that we take out the resistors, the burned out resistors, and yeah, so let's go from there. So next is to take out the chips here, the old resistors, 47 ohm resistors. First, second, third, and the fourth, our last one. Right, again, it's the same procedure. We clean it and then we go ahead. Okay, so our new resistors are in, and now we can go over to our power amplifier chip. So look, this is here now a very crucial step. So you see I've screwed the new power amplifier to the board, just in order to be able to align here all, you know, the pins. And you should look that this ground pins, and as well on the other side here the ground pins, so all that needs to be aligned, and the distances here from the pad to the pin on both sides should be more or less the same. So that is very important, that you will be able finally to put, you know, your both screws here through the PCB, and you will then be able to connect it with the chassis. And if this here is not good aligned, you will never get your screw through the PCB in order to get them into the chassis. So that step really needs to be done very, very carefully. What you can see here now, I have already done 2 solder joints, and now I'm able to take off the screws, and we can check if it all fits into the chassis, and then of course we do the rest. So the screws are out, and now the point is to get it here into our chassis. So that is just to check that everything is fine, because there will be no chance to get the amplifier out again if we need to correct something. So therefore it is always better to check it, even if you are maybe not that much experienced, because then you can maybe, if needed, correct it. But if you have done everything, then that's simply game over. So you see, I was able to get the both screws easily in, so that means that our alignment is simply fine. And now we go and do the rest of our connections, and then we should already be at the point where we can everything reconnect, and then we can of course test what we have done. Okay, so as you can see, our new chip is in, and believe me, it is not an easy task, because all the ground planes we have here, and I said it before, are very, very large, and you really have to fight all these ground planes. So yeah, it is not easy, but you see it's in, and now we can go and testing. Now we first clean the heatsink grease, the old away, and of course we prepare all with new and fresh heatsink grease, and then we should be fine. Of course, so we do everything new, as you can see, and here as well. So that is our pre-driver, which is for all stages, as well for HF, as we said before. And yes, we put a little bit down here as well, and here not too much, but a little bit. Oh, that should be fine. And now we can put our power amplifier board back in like so. And now let me simply do all the connections, the screws, and then we can go for testing. And of course, we should not forget this heat pad. Very, very important. Alright, what we all can see is that our power board is in. But what you can see as well, it is all prepared to do the alignment for bias. So we have here different stages. So the pre-driver, the pre-driver, the driver, and then finally our power amplifier. And we need to align everything according to our service manual, because if the setting is wrong, in worst case, that can be the reason why a component fails. So therefore, we are really focusing on that and do all settings now. According to our manual, the pre-drive state idling current adjustment should be 40 milliamps plus minus 5 milliamps. So let me check what we have. So amp meter is adjusted, and when I now press PTT, we should see the current, and you see it is 34. So ignore the minus. So it depends how I have connect my leads here, my test leads, but that does not make any difference. So important is okay. So that is 34 milliamps, and it's a little bit below the allowed error, but let's try to bring it more or less in the right position. Okay, so let's start aligning. Let's see if it changes when we turn. Yes, you see it is changing, and let me try to get it. Yeah, look here. So that is nice. 39, perfect. Let's go ahead. Okay, and look here, so that you have seen it once, how it looks like in the service manual. So the next stage, that is what Yaesu is calling it, drive stage idle current adjustment. I would say that is the second pre-driver. Anyways, they call it drive stage. And what you see, we have to connect it to another test point, and we should read 100 milliamps, and that is what we want to check now. Maybe first that you can see it on the board. So down there I have connected my both test leads, and they are connected to my amp meter. Okay, and now we expect 100 milliamps. Let me see what we have. 94, 95, so that is definitely very, very close. So normally we would not really need to do something, but let me increase it a little bit. So the allowed error is 10 milliamps plus minus. So therefore, look, 89 is just fine. As we can see it here, we have two PA transistors on our semi-final, and that means we need to adjust the idle current independently with two pots. You can't see the second one, so here's one and here's the second one. So that means first this and then this. That means I have turned both pots down to 0, and when we start we should not see any current, and then I do the first adjustment up to 600, and then I do the second adjustment up to 1.2 amp, and then our semi-final should be fine. Alright, so let's start. First of all, when I now press, yeah, you see there is literally nothing, which is fine. Now let me go down to one of the pots, and okay, now we start transmitting, and I try to bring it up to 600 milliamps, of course, not microamps. Let me see. We are getting closer, and yeah, a little bit less. Okay, let's say here it is fine. And of course, now I go over to the second pot, and there we try to bring it up to 1.1 amp. Okay, so that may go up, and let's see that we increase it to 1.2. Oh, that's too much, of course. 1.2. Come on. That is, as always, very touchy. But look here, that is fine. Very, very nice. So that means our semi is fine by now. Okay, so almost ready. I had a little issue here with this potentiometer. So I've put in now so-called precision one, because the old which was in was jumping, you know, and that might have caused the problem with our power amplifier. So now with the new precision pot, it is much better, and well, everything is now more or less stable. Okay, so we have set it now to the 70 centimeter one band, and I'm curious now what will be our output power. Alright, so after repair, that is always the question. Okay, let's see what we get here. Ah, okay, so that is nice. It is good. Now let me put it over to our 2 meter band, and of course there we are interested as well. Let me see, we should get it here. Let's set it over because I have here the receiver on as well, and there you can see a nice sign and a good and clear yeah, sign signal what we see here. Now when I switch over to transmit, let's see what we got here. 48 watt, so perfect. Everything is definitely fine. Our new power amplifier is in. That means we are definitely at the end of our video. So unstable, what I said before, because you know, this radio is really sensitive if you do not have all the shieldings, and well, you know, that is what you get here over the unit. So it is very sensitive if it is not completely shielded, and therefore that are the rest work what I have to do. But anyways, radio is working, everything is fine. Bias is completely adjusted as you have seen it. So, that's it for the day. Thanks for watching and catch you next time.